Hi class, let me draw for you a few pictures related to Chapter 2. The title of Chapter 2 is the composition and structure of the atmosphere. And so we will look at the atmosphere in terms of the composition, the gases that make up the atmosphere. And we're going to start off by talking about a dry atmosphere. And so what I mean by that is for now, we're not going to take into account water vapor in our atmosphere. Water vapor is the only gas in our atmosphere that really varies in terms of how much of the atmosphere it comprises from location to location. And you already knew that. If you look at the Sahara Desert, there's virtually no water vapor in the atmosphere. And if you were to go vacation in the Amazon rainforest, you would probably get sick of the humidity after not too long a period of time. So water vapor is the only gas that varies across the Earth's surface from location to location. All the other gases remain pretty consistent in the amount of the or percentage of the atmosphere that they make up. So we're going to talk about atmospheric gases in terms of major atmospheric gases and minor atmospheric gases. So let's take a look at the major gases in our atmosphere to start off with. And let's define what we mean by major to start off with. So when we say major, generally speaking, they're not major because of what they do. They're major based on the percent of the atmosphere that they comprise. So major gases are major based on the percentage of the atmosphere they comprise. And there are three gases that we consider major gases in the atmosphere. The first is nitrogen, N2, it's molecular nitrogen, and this makes up about 78.08% of our atmosphere. So over 3/4 of our atmosphere is nitrogen. It's a nitrogen-based atmosphere. Lucky for us, about 21%, 20.95% of our atmosphere is made up of oxygen. And argon, now you're going to look at this and you go, really, that one's considered a major gas? Well, yeah, it is. Argon makes up a little bit less than 1% of our atmosphere, but it's still considered to be a major gas. Nitrogen, oxygen, argon are the three major gases. The three of these combined make up 99.96% of a dry atmosphere. Okay, when you think about it, all the rest of the gases in our atmosphere combined make up about 0.04%. And so if I look at these gases, these really are not greenhouse gases at all. So that tells us that the greenhouse gases in our atmosphere can make up a maximum of 0.04%. And in reality, most of the rest of the gases, what we call the minor gases, are greenhouse gases. Okay, so let's take a look at those minor gases. Okay, so minor gases over here. And again, our definition of minor gases, these are gases that are, again, based on the percent of the atmosphere they comprise. Okay. So most of these minor gases are greenhouse gases. And so even though they're minor, these are extremely important gases. Extremely important. they may make up very little of our atmosphere, but they are extremely important in terms of our climate. They're extremely important in terms of our vegetation that we find at the surface of the Earth. They're only minor because they make up very little of the atmosphere. Otherwise, they're really, really important. Okay? So the first minor gas we'll talk about is carbon dioxide. That's the one you hear about quite a bit, referring to global warming. And this is the most abundant of the minor gases. Carbon dioxide makes up about 0.04% of our atmosphere. It's critical. If you remember from high school biology, it's critical for photosynthesis. So plants will take in carbon dioxide in photosynthesis and will give off oxygen. And so it's important for plant life. From the terms of climate, it's extremely important because carbon dioxide is the most abundant greenhouse gas, which means that when the Earth's surface gives off infrared radiation, the carbon dioxide in the atmosphere will absorb that infrared radiation and re-radiate a lot of it back down to the surface, almost like a blanket effect. And it will keep our surface warm. And as we increase the concentration of carbon dioxide in the atmosphere, more infrared radiation is being absorbed and more is being sent down to the surface, which is warming up the Earth's surface. Another greenhouse gas that is a minor gas is methane. Less abundant compared to carbon dioxide, but again, it's a greenhouse gas. It absorbs infrared radiation and re-radiates that energy back down to the Earth's surface. Ozone is another considered a minor gas. It's another greenhouse gas, but even more importantly, there's a layer of ozone in the stratosphere that absorbs potentially harmful ultraviolet radiation from the sun. As the sun's rays make their way down through the atmosphere, the ozone in the stratosphere will absorb a lot of that infrared radiation, ultraviolet radiation from the sun. That ultraviolet radiation is what is responsible for suntans, sunburns, and potentially skin cancer. Melanomas are often caused by human bodies absorbing ultraviolet radiation from the sun. Another gas that we're going to talk about is, I've mentioned we're talking about a dry atmosphere, but water vapor is considered another minor gas, and it is a critically important greenhouse gas. In fact, water vapor is the strongest greenhouse gas in our atmosphere, so we have to consider that. Another minor gas is what are called aerosols, kind of a catch-all phrase. These are little tiny impurities in the atmosphere from both natural and anthropogenic sources. And the importance of these aerosols are that they will serve as what's called condensation nuclei, so that water vapor in the atmosphere can condense onto these little impurities. So every little tiny cloud droplet you see, every snowflake, every raindrop has at the center of it an aerosol, a little impurity onto which water vapor will condense. And so with no aerosols in the atmosphere, we wouldn't have any clouds, we wouldn't have any precipitation. But I don't want you to worry because there are plenty of impurities in our atmosphere. Okay, so next what we're going to talk about is the structure of the atmosphere. So we looked at the composition of the atmosphere. Next we'll look at the structure of the atmosphere.